If you watch my channel on a regular basis, you'll know that I don't often do reviews, but I picked up this piece of equipment recently and it was extremely cheap. I paid £135 for it, and I'm always interested in trying to get people into electronics, but of course one of the obstacles in getting into this as a hobby is the initial high cost of some equipment. So because this was so cheap, I got hold of one. It's partly for a project I'm about to start, but also I thought at the price and with the specification it claims, it was worth having a look at. And as I say, I don't normally do reviews, but because this has pleasantly surprised me, I thought I would make a quick video. This is not going to be a full review by any stretch. I'm sure there are review videos of this piece of equipment out there. But anyone that's interested in getting a very cheap but what seems to be quite capable arbitrary waveform generator, this might be a good initial first buy. You can easily spend £300 or £400 on a 20 megahertz generator, and this is an 80 megahertz generator, so we'll see if it actually does deliver on what it claims. If you're interested, it's a Juntek, that's Juntek PSG9080, and it claims 14 bits, 300 megasamples per second, and it has quite a lot of features, far more than most of my other generators do. And it's got a whole range of kind of nice to have features that you don't always get on a lot of signal generators, let alone very low end ones like this. Now when I opened it I was a bit alarmed, to be honest. It's so light, I thought I'd been conned and it was an empty box, but it does work, it does come to life. I think they've missed the trick here. They should have put a metal plate in the bottom just to give it some weight, and it would have felt a lot better. Although it's very low end plastic, is not the best quality. It is better than I was expecting. It's actually quite a nice quality finish, and it feels quite nice. Very low end devices often feel really horrible, but although this does feel cheap, it does not feel horrible. It's actually quite nice. All the buttons work nicely. The encoder, it's got a very nice feel. It's not clickable, but it's got a very nice feel to it. It's got just about the right amount of detent feel. Reasonable quality connectors. They're not obviously going to be top end at this price, but they are certainly adequate for the job. But one thing that surprised me was that it works a lot better than I was expecting. Usually low end things, they have a habit of not working at all well. This does have some issues, but as I say, this is not going to be a full review. I just wanted to show this in case anyone out there is looking to get into the this is a hobby and needed a generator. Before we start this, we're going to go down the Dave Jones route. I'm not going to switch it on, I'm going to take it apart. Okay, so that's what's inside. Not a great deal at all, just a very simple switching supply, and then we have everything on a single control board, and then there is the control and connector board at the front. Very nice, neat layout. I am very impressed with this, and the board itself seems to be very high quality. So it looks like the brains of this is all built around a Spartan FPGA, and all the wiring is very neat. It's actually a very nice design. There is a screw here that's for grounding. That's not to ground the rear case, it's just so that you can have access to a ground screw if you want to connect something to it. I'm not quite sure how you'd go about this, because if you take the screw out, then the nut will fall off the inside. So I'm not quite sure exactly why that's there. As I say, looking inside, it all looks nice and neat and tidy. The board does say Juntek on it, and so it appears it is made by them. It's a very impressive looking board. I'm not going to take it out any further than this. I just wanted to see what was inside. I do like to take these rubber bumpers off when I put my equipment on the rack, but unfortunately these won't come off. They're moulded into the end covers, so I can't do that, but it's not too bulky anyway, so it's not too bad. I will be taking the bail off. I'll leave it on for now just so that it makes it easier to video. but I assume I just rotate this all the way until the keyhole slot is lined up, and then it just lifts out. So very nice. It's very impressive. I mean, even the quality of this plastic is quite good. It's not the usual flimsy. It's actually quite stiff. It's quite a nice stiff rigid case. But as I say, the quality of the board seems extremely good. That is very impressive for this price point of equipment. So okay, well that's what's inside. As I say, I'm sure there are reviews of this, so I just wanted to show this, and we'll give it a quick workout, and I'll show some of the features that I particularly like about it. So I'll just get this screwed back together and we'll get it switched on. Okay, I've got it screwed back together, and just to have a quick look around it before we power it up. Proper mains input with a mechanical switch. Input output does come with an English manual, by the way. It can be driven direct from 5 volts, USB, and then we have sync in and out. It tells you on the back legend what the connections are for. So again, very nice professional layouts. It feels good. There's nothing wrong with it. The rubber bumpers do protect everything, so they extend past all the protrusions on the back. Even with the tilting bell, they've gone to the time and trouble to put rubber inserts onto it so it doesn't slide around the bench. And even though it's light, when you put it onto the bench, you can push all the buttons. It doesn't slide around. Most of these cheap hard plastic cases tend to slide around the bench when you try and use them. This is nicely planted, it doesn't move at all. These are not solid. There is a bit of give in them, but not a great deal. I would have preferred it if these were removable, but you know, it's not too bad. It's not the end of the world. So quite impressive. So the next thing to do is we'll get it switched on. Okay, we'll get it powered up. There is a mechanical switch on the back. No indication with that on. There's no heartbeat indication. We'll try and power it up. Okay, so it's a nice, clear, bright display. You've got both channel output settings on the same screen at once. And this has a whole range of features that I was quite surprised by. So as I said, this is not going to be a full review. This is going to be just a very quick run through. And in particular, I want to show some of the features I particularly like. The first of those was when I first switched this on, the frequency wasn't too far out, but it was about 30 Hertz out at 1 megahertz. So if I select the frequency, and this is very intuitive. I haven't read the manual for this yet. I'm just going through and seeing if I can operate it without having to spend hours reading a manual. And so far everything has been very intuitive. If you want to enter something, you just select it, it's highlighted, type in the number that you want. And one of the reasons I bought this particular signal generator over other cheap ones, you can get other ones about the same price, but this has a numeric keypad, and the others you had to kind of dial in the frequency, which I find very irritating. I just like to be able to type in exactly what I want. And so we've now got this set up. Before we look at this on the scope, I just want to demonstrate one of the features that I do particularly like that's included in this. So I'm going to plug this into my Philips PM6680, and then I'll show you the screen on that in a few seconds. Okay, so we're connected now to a high precision frequency meter. I don't want to move it down onto the bench. It's the one with an oven and oscillator, and it's always left switched on and running, so I don't want to power it off, but I will move the camera in a second so you can see that. At the moment I've got it gated for 1 second reads, and it's reading well, if I want to, I'll type in exactly what we want, so 1 megahertz. Oops. So we've got 1 megahertz set on the generator, and the PM6680 is reading just a few hertz away from that. But what I'm trying to demonstrate here is a feature that I really do like on this. I haven't really seen on many of this type of price point device is this frequency fine tuning. It allows you to adjust, like calibration, but allows you to adjust very easily the frequency accuracy, and all you do is you just dial it up and down to exactly what you need, so you can get it to give you a very accurate reading. And it does allow you to get within just a few hertz of the correct reading. So the step size seems to be about 1 hertz at a megahertz. So I'll just move the camera now so that you can see the PM6680. So as you can see, it's very close to being spot on. It's within about 0.2 hertz, which is amazing for a generator at this price point. And of course, having the ability to do that means that you can always adjust the generator to give you quite a precise output, as long as you have some reference to go by. So just going through the settings, you've got all sorts of options here that you can set and adjust. You've also got fine-tuning of the amplifier outputs, so that's amplitude, and it means that you can adjust this to give you a very precise output. In fact, you can adjust this for short-term precision that's better than any of my other arbitrary waveform generators, apart from the top-end ones that cost several £1000s. And that is quite nice. It means if you've got a short-term experiment and you need precision, you can still use this. It wouldn't be any good a week later or a day later. You'd have to repeat the calibration process, but it does mean that you at least have some kind of transferable reference that you can use to generate the signals, and that is quite a nice feature on such a low-end piece of equipment. You've got all sorts of other options in here, of course, and what we'll do now is just have a look at a few other of the features on the scope. Okay, so I've got 1 megahertz set on the generator. I've got it connected to the scope using the cable that came with the generator. I've got the output of the generator set to 50 ohms, and I've got the input of the scope set to 50 ohms, so you should get quite a good match there. And we'll set the generator to sine wave, all very intuitive to use. You just select whatever you want to adjust, it's highlighted, and then you can either dial in the value you want with the encoder, or you can enter the value. It can store up to 99 arbitrary waveforms on top of the ones that are built in, and you can just type in the number that you want. So in our case we want to enter 0, and that's a sine wave, or you can just adjust it if you know what it is you're looking for. Very nice looking sine wave on the scope. Goes down to a small fraction of a hertz, and of course up to 80 megahertz. So we'll go up in increments. We'll go up to 10 megahertz. Still looking quite good. The output of the generator is set to 3.6 volts, and we're getting 3.58 volts on the scope. The maximum output voltage you can get from the generator does drop as the frequency increases. It's a maximum of 25 volts. There is a kind of an issue with it, in as much as the peak output is 25 volts. But if you try to set an offset, then let's say for example you have a sine wave set, it will start clipping the output. We'll have a look at that in a few minutes, but you just need to bear in mind that the output is variable with frequencies. So below, or rather above 60 megahertz, we're limited to 3.6 volts, and I believe up to 60 megahertz we can go up to I think it's 5 volts, and up to 20 megahertz we can go up to 20 volts, and up to 1 megahertz up to 25 volts. So it's quite a good output at low frequencies, and a reasonable output at the higher frequency end. Okay, so at 10 megahertz we'll go up to 50 megahertz, and the output has dropped a little bit. We're down to 3.48 volts peak to peak. I suspect most of that is at the moment is lost in the cable. Okay, and we'll now go up to the full 80 megahertz. The scope is showing us to be fairly close on 80 megahertz, but I have checked the calibration of the frequency throughout the entire range, and once you adjust it, it is very consistent, and it is within a few hertz. I think it was within 2 hertz at 80 megahertz, which is quite astonishing for such a low-end piece of equipment. Okay, so we'll now go down to a lower frequency. Now, there are some issues with this. There are a few small bugs in the firmware. Well, I'm not sure if you call them all bugs. For example, if we select a square wave at this frequency, it just looks like a sine wave on the scope. But as we come down in frequency, then it does start to look a bit more reasonable. So if we come down to 5 megahertz, then we do get quite a good square wave. We'll go up to 10 megahertz, and again the specification is quite accurate on this. It's not kind of pulling any fast, and it's not playing fast and loose with the specification. It does seem to be a fairly honest representation of what the piece of equipment can do, and as you can see, even at 10 megahertz it's looking quite good. If we go up to 20, then it's still looking quite reasonable. In fact, this looks better than my other arbitrary waveform generators that are rated to 20 megahertz. Now, of course, this is rated higher, but even so, it's still a much better output for a very low cost piece of equipment. But you can go up well beyond where it is capable of producing a decent square wave. But I actually quite like that. I like the fact that you can push it a bit beyond what it's supposed to be able to do. I think it's supposed to go up to 20 megahertz for the square wave, but I would say that you can get up near 25 or even 30 if you want to really push the definition of a square wave. It is still more square than sine, up to quite a reasonable level. Okay, but next thing is to look at the output level. So if we go down to 1 megahertz, turn the scale down on the scope to a 5 volts per division on the scope, and we can of course adjust the amplitude. So we'll put in 10 volts, and you can see that is indeed what we're getting on the scopes, say 9.8 volts. If we start going up in frequency, then the value will eventually start to drop. So if we try to adjust that, and so we'll now try a higher amplitude again, and that's fine. And finally up to 25 volts. At 1 megahertz it will limit you to 20 volts, but below that, so if we go to, for example, 100 kilohertz and then back to amplitude, we can now go up to the full 25 volts, which is quite impressive. It's quite a good level of output. As I say, you are limited based on frequency. If you go to a higher frequency, then it will reduce the output level. So we're now down to 20 volts, but even so, that's still a very good output, and it will maintain that up to quite a high frequency. So if we now go up, you'll see that at 10 megahertz, just over, it drops to 10 volts. So it's quite a well-behaved piece of equipment. It doesn't force things when they're not necessary, but it does make sure that it does at least try to deliver on the specification. You've got an offset, and this is one of the probably the only issues with this that I've found really, is that if we set a sine wave, for example, and if I set 15 volts as the amplitude, we can see on the scope that we are getting a 15 volt signal. But if I now try to put in an offset, so we'll increase it 1 volt at a time, you can see on the scope it is working fine, but the output of the amplifier does seem to be independent. It's kind of fixed, so it's not there is no overhead to produce the maximum voltage output plus the offset, so it will start to clip once you get up to what is the maximum voltage output limit, and it does that irrespective of what you set in terms of the amplitude of the signal. So of course if we now reduce the amplitude of the signal, then it will reduce and it will eventually stop clipping. So it's going up at the bottom, but also it's coming down at the top, and you'll see that once it gets down below that maximum peak value, then it stops distorting. So that's the only thing to be aware of with this. If you do have an offset, then you won't really be able to achieve the maximum peak output. So that's really the only things I found with this that really I wouldn't say it's a fault or a bug, but it's something you do need to be aware of if you're expecting to be able to use the maximum output. We do of course have the whole range of arbitrary waveforms available. So now that's normally where very cheap pieces of equipment like this end. They don't normally have any other additional features, but this has got some quite nice built-in features that you may find extremely useful if you're just getting into electronics and you don't want to have to buy lots of different pieces of equipment. Now one of those is the ability to measure frequency. So if we press the measure key, okay, so I'll connect the external generator to the external input, switch it on, let's set to 1 megahertz, and you can see we are getting a reading very close to 1 megahertz, and that is actually within the spec of the other signal generator, so works quite well. It will also count, so if you want to count rather than have frequency, you can do that as well. You see it's now counting pulses. There's a whole range of different options you have for this. So on top of this we can store different setups. It's got a program option as well, which is extremely nice, and something I've been playing with. You can enter quite detailed and complex programs within this. It's got sweep capability. It's got voltage controlled oscillator capability, so you can feed in a voltage and use that to control the frequency, and of course you can feed in external modulation. You can also use internal modulation as well. As I say, you've got this program feature, which is quite complex and quite a nice feature to have. And again, modulation, you can set many different types of modulation on here. And you've got bursts, FSK, PSK, ASK, PM, FM, a whole range of different modulation types. You can feed that in externally, or you can couple it to internal signals. So there's a whole range of things in here that are extremely good features, and they do work quite well in this piece of equipment. I keep saying it's very low cost. But really it's the equivalent of having maybe 2 or 3 different pieces of reasonable quality equipment. It's not going to be top end, but I'm really hoping this company moves on and starts putting this quality of device into better quality cases, and I think they might be a company to keep an eye on. I think this is an extremely nice piece of equipment. And I can see that although I bought this for a particular project, I wasn't expecting to use it much beyond that. It has a certain feature I wanted, but I can see I might be using this quite a bit in the future. It has surprised me, and that's the reason I made this video. It's well worth taking a look at if you are currently searching for a low-cost programmable generator. This is well worth the money that I've paid for it.